I have another 5 minutes in writing down very important notes. Coming back, wrapping up, in the indirect integral equation, here is indirect integral equation, we will have u of x equal integral of s of xi, u asterisk of x and xi, phi of xi. Okay, and we differentiate with respect to d by dx alpha of x and multiply by n alpha of x, will get q at x equal integral over s of xi, q asterisk of x of xi, phi of xi. Okay, in the direct integral equation, I'm going to write it here. In the direct integral equation, we will have u of xi, remember here, we'll have u of xi equal to integral of gamma of x, u asterisk of xi and x, q of x minus integral of q asterisk of xi and x over gamma of x, u of x. Remember this term here. Okay, but I swapped the point x and xi here. This is for notation only. I like to write the notation like that. When I use indirect form, I use the notation like that. When I use the direct form, I use the notation like that. Professor Banerjee always swaps this, and sometimes he puts the q before u asterisk of x. He has his own school in doing that. Okay, this is the direct integral equation. We differentiate with respect to the coordinate of the source point, dx alpha of xi. We get the derivative for this one, du of xi by dx alpha of xi equal to integral over x du asterisk of xi and x over dx alpha of xi q of x minus integral of gamma of x dq asterisk of xi and x over dx alpha of xi u of x. So here we differentiate with respect to the source point. Here we differentiate with respect to the field point. Here we have series of xi's, sources xi's, and we get the superposition of them at point x. The other way around with the direct integral equation, we write integral equation for a certain xi. Okay, so we write it here again. We have on the boundary here point x, and we have series of xi's, and we get the effect here. And here we have, for each point x here, we have a certain point xi, only one xi, and we write complete integral equation for this. Still one thing to go. When we have body force, what shall we do? We will have particular integral. Okay, we'll have particular integral. I will write it in a fast way, and then we're coming back when we talk about transformation of domain integral to the boundary. Definitely, we will have here, we will add at this point, we will add the particular integral, which is integral of u asterisk between the point x and the point y inside the domain times the particular integral of the point inside the domain. And here we have to compute this particular integral on the gamma of y, or the domain, the domain of y. The domain of y, the domain of y. This is very important. This particular integral has nothing to do with xi's, has nothing to do with s of xi. Here, remember, this is s of xi. This one has nothing to do with s of xi. Okay? The particular integral here will appear here again at this point as integral over omega of y with u asterisk of xi and y times b of y again, which is very similar to this one, but this one the point x appear, this one the point xi appear. I will give separate lecture to demonstrate the difference between the point y, s of xi, gamma of x, and all of this point. And I will start the coming lecture clearly with the difference between these points in particular. The direct integral equation is a bit different from the indirect integral equation. This one has its advantage and disadvantage, and the same this one has its advantage and disadvantage. But up to now, I will stop this lecture because we actually got a lot of mathematical terms, but this is the real boundary elements. We can say this is the first lecture of real stuff in boundary elements. Thank you, Paul. Thank you, Paul.
Yeah, okay, thank you, Professor. Yeah.
If we
So
have any
anyone has some questions or comments?
I don't think I hope they is still alive or something like that.
So as I see some in some paper, the people they said the indirect formulation and the direct formulation they are the same.
We have only
equivalent.
one paper. We have only one paper. I said this before, written by Professor Roy Butterfield with Carlos Brepi. It is in the early volumes of applied mathematical modeling, I think, is equivalence between the two methods. Actually, if you condensate phi, if you eliminate phi and condensate the direct integral equation, you will end up to the direct integral equation. But this is not easy to be done. This is in philosophical way. Because why I'm telling you that, Paul, because actually, as you know, this is what we call it the single layer potential, and this is a double layer potential. Actually, this one is a series. It is not only the first term. This is the first term for monopole. But if you go for, again, you can use dipoles, you can use quadrupoles. How can I use to condensate, to eliminate the source term, the intensity for sources and the intensities for dipole is almost impossible. But we put it in philosophical way. Maybe when I talk about dipoles at the end of this lecture series, I'm planning to bring this these papers, and I will share the screen with you, with our great students here, and I will show how to eliminate these parts. But from my opinion, it is in philosophical way. It's not in mathematical way.
Okay. Yeah.
Actually,
so
day by day, and lecture by lecture, the level of philosophy or mathematical philosophy will increase. I hope people will stay with us. I hope.
Yeah.
But this is a testy part of boundary element method. This is the testy part. We are talking actually about mathematics. Okay.
Yeah.
So if nobody has questions, we can say goodbye now.
Say if someone has a question. If no, so let's thank Professor again. So finish the lecture 4 and see you all next week the same time.
Thank you, and see you next week.
Yeah.
Bye.
Yeah. Okay. Bye.